Today we're going to be talking about how to select an optimizer based on whatever module you're using. The current generation of the power optimizer is the P5 series. The optimizer comes included with an MPPT. It is NEMA 6 rated, which means you can submerge it underwater and it will still work. Of course, this is only if the MC4s are connected. It's rated to 185 degrees Fahrenheit, has a maximum efficiency of 99.5% with integrated safe DC functionality. So if you're concerned about rapid shutdown requirements, safe DC functionality meets all of those rapid shutdown requirements. There are a couple of varieties of optimizers available. You can get a SolarEdge optimized solar panel where the optimizer is integrated into the junction box of the module itself. We have frame mounted optimizers, which have a bracket designed to mount to the frame of the module, or you can get our standalone optimizer, which basically bolts to the rail or a third-party frame mounting bracket. For the residential market space, we have 5 optimizers available: the P320, 370, 400, 405, and 505. They all have unique characteristics. For example, the 320 is really designed for a 60-cell solar module. The 370 is designed for a 60-cell solar module that may have a 5-inch cell. Usually that has a higher current output. The P400 is designed for those 72 or 96-cell solar modules. The 405 is really designed for thin film. So if you're using a thin film module, typically those have a really high voltage at 125 volts DC for max input. The P505 is designed for bifacial modules. With bifacial modules, you're likely to get more energy captured from the backside of the cell, increasing the amount of current. The rule of thumb is if you have a module that is readily available, SolarEdge has an optimizer that will work with it. So how do I check my module compatibility? All you have to do is look up the record low temperature for the location that the installation is going to occur. So for this example, I looked up the zip code for San Francisco and found that the minimum temperature was -5 degrees Celsius. I take that record low and I subtract it from the standard test condition. That is 25 degrees Celsius, and I find a change or a delta in temperature of -30 degrees C. So the reason I'm worried about the record low is, as we know, heat is a big resistor, and as things heat up, our voltage will drop. Conversely, voltage increases when weather is colder. So I don't want to overvolt my power optimizer. So I look at the module data sheet and I find this is a module that is 265 watts. Its VOC is 38.1 volts and its temperature coefficient is -0.33% per degree Celsius. So how do I use this information? I take my change in temperature, so my -30 degrees Celsius, I multiply that by my temperature coefficient of voltage, -0.33% per degree C, and I find 9.9%. I take my 9.9% and I add that to my 38.1 volts. So I know my voltage is going to change a little bit less than 10%. So we find that our voltage is 41.87 volts if San Francisco gets to -5 degrees Celsius. So then I take that information. So here's my calculated numbers. The VOC is 41.87 volts. VMP at the lowest temp is 33 volts, and at the highest temp is 29.18 volts. And I compare that to my optimizer data sheet, and I see that the P320 has a maximum input of 48 volts. My calculated value is less than 48 volts. Therefore, the P320 is the optimizer that I can use. So if you're a person that likes to use Excel, just plug this equation into an Excel spreadsheet. Add the characteristics of your module. Your P max is 290. Your VOC is 45.3 volts. Your short circuit current is 8.62 amps. Add your temperature coefficient of voltage, -0.33% per degree C. Enter all of those values and you find your V max for this region that was -40 degrees Celsius to be 55 volts DC. Compare that information back to your optimizer data sheet and you will find that the P320 does not work because the maximum voltage has exceeded the allowable of the optimizer. So that would bump us up to the next optimizer, which would be the P370.
For additional information and access to more in-depth tutorials, go to SolarEdge.com, select Login and e-Learning to get access to the library of SolarEdge learning materials.